welcome everybody to what is now already our 6th virtual ethical innovation lecture, or VAIL as we call it. And in this series, as always, I want to make sure that you know what our agenda is. So what we want to do is we want to help disseminate some of the very interesting insights that we come across via the actual authors of these insights. And also we would like to spread word about some initiatives, or just spark the debate, or any debate about mostly the ethical and societal aspects of technology in general. Most of it is AI focused, but we go along with every interesting topic that we see. And today we have a very interesting topic, I think, but more on that later. We are very happy that you fit this small lecture into your busy schedule. We designed this format such that you can do so. So it's kind of a lunch seminar, if you will, intended for those that don't read or think about ethics of technology every day, and provide a brief introduction into this. I would like to express my gratitude because the VAILs are supported by the Academy of Humanities and Sciences in Hamburg. Thanks for the financial support. Thanks also to Noah Leinweber as my student assistant, who is helping me very much in preparing the VAILs. And also I'd like to continue with a brief word about us and who we are. We are the Ethical Innovation Hub, which is a research group that is a joint venture of both the Institute for Electrical Engineering in Medicine and the Institute for the History of Medicine and Science Studies at the University of Lübeck. And our agenda is basically that we do research on how ethical considerations can be used as a driver for innovation in technology and development processes, how to integrate them there, how to make the best value out of them, and methods to get multiple disciplines talking with each other, such that technological innovations are designed for the benefit of society in general. And we already had one very interesting VAIL this term, done by Hermann Dieber-Fischer, who talked about ethics and quantification. Today we have Andrea Aller Tubella, who will talk about contestable black boxes. More on that later. What we'll also have in this term, so there's no VAIL in June, but 2 in July. Usually we have a once per month kind of agenda, but that didn't work the other way. We have Aidan Pepin from the Ada Lovelace Institute, who will talk about the datafication and the boundaries of health. And we'll have Rob Sparrow from Monash University. That's, I think, as far as we've gotten so far in our lecture series. So from Australia, he will be speaking about his paper on high hopes for deep medicine. So I think there's quite a lot to look forward to. But first of all, I'm looking very much forward to the presentation of today's speaker. I already said it. Andrea Aller Tubella is a senior researcher at Umeå University in the Responsible Artificial Intelligence group of Professor Virginia Dignam, who I think is kind of famous. Also, she's consulting the EU on important matters in AI. So this is a very interesting and I think also very, very, very flourishing group. And we are happy to have you here as our speaker, Andrea.
Thank you.
I reckon that you were a postdoc in Paris before that, and even before that, you obtained your PhD from the University of Bath under the supervision of Alessio Guglielmi. Is that right?
That is very accurate.
And you are coming more from the computer science perspective, right? So your typical research areas actually include logic and proof theory and deep inference. So I think that's also very interesting, having you talk about implementing moral bounds for AI behavior. And basically, without further ado, I'm very happy and very looking much forward to your presentation. There's only one more thing which I stated before, but if you have any questions during the presentation, please use the Q&A section. This will be the place where I monitor the most. If you have any questions later on, we'll all also be able to talk using our microphones and discuss the work. And with that, the floor is yours, Andrea.
Thanks a lot. Thank you for having me. I don't know most of you, so I thought, oh, there is something I haven't tried, which is passing slides. Okay, it seems to work. So I thought that the first slide could be indeed introducing myself and our group. So we are the Responsible AI group, which look at a lot of the questions that indeed you mentioned at the interplay of ethics and society and economics and law with AI in particular. And the first question I am always asked is, where is Umeå? So I put a little map there. Umeå is in the north of Sweden. It's a beautiful city. So I hope that one day you can all come visit us here. And we are a medium-sized group, perhaps. And we cover a lot of research areas, including design methodologies for human-centered AI, participatory frameworks, more technical frameworks, which is what I'm going to talk about today a little bit. So you can always feel free to reach out to us if you would like to know more. Okay, so like Christian mentioned, oops, today I'm going to talk about contestable black boxes. And this is based on a paper that we published a few months ago. And actually, I am going to spend most of the time in the talk introducing the problem. And this is not going to be a very long talk because I hope we are going to have some nice discussion at the end. So please really feel free to write any questions and I will be very keen to have some discussion after this. So, okay, the main word in this title is contestable, right? We all more or less have an idea of what black boxes are, which is basically some sort of process that we don't really know the inside of or how exactly it produces its outputs. But what do we mean when we talk about contestability? I think that contestability is also something that we're pretty used to. I mean, we know, for example, that when students are not happy with their grade, they can go and complain to the professor and say, I don't think that was fair. Can we have a look again at my grade? And of course, in more serious and more formal ways, we have in the legal system, for example, many tools for appealing when we think that the decision was not taken correctly. And so it has been argued that individuals that are affected by predictive algorithms, decisions that are taken by these kind of algorithms, should also have this type of right to appeal, to protest, to have the decision looked at and checked again to see if the process was correct and if the decision is correct. And in fact, the GDPR, which you may be familiar with, the General Data Protection Regulations, the very annoying thing that makes you now have to press whether you want cookies or not, actually also enshrines that. So it says that when a decision that significantly affects you relies only on automated processing, you should have the right to contest this decision. This right should be guaranteed. So when we talk about this kind of right, right is a word that I am saying a lot. Of course, there are a lot of perspectives that come into play. There is the policy perspective. I mean, we need policymakers to say what are the types of decisions that can and should be contested, what type of review should be offered. The legal perspective of actually enshrining this into text, what kind of assurances are needed to guarantee rights. There is the explainable AI perspective. So how do we explain decisions so that individuals can decide whether they want to contest? Anyway, there are a lot of different perspectives. And in fact, since we wrote this paper, there's been a very nice paper that I have here at the bottom from Lyons et al. That presents all of these perspectives and focuses a little bit more on the HCI perspective. So in case you're interested, I would also point you to that one. And my disclaimer here is that I myself, I am not a lawyer. I am not a policymaker. So the perspective that we're taking in this talk is about tools. What kind of tools, what kind of technical processes do we need to make sure that when we have these predictive algorithms, we can evaluate their decisions, observe them, understand them, and contest them and see whether the decision was taken according to what we wanted or not. So this is the perspective I am taking in this talk. And if there is one thing that I would like everyone to take away from this, is not even about the tool that I will propose at the end, or the kind of process that I will propose at the end, but rather that this is an area that needs a lot of research, and that a lot of the time there is research on some related topics, for example, explainability, but the right to contest itself has been widely overlooked. So in fact, of course, when we talk about the right to contest, there are a lot of other ideas that come into play. And these are all of the keywords: transparency, explainability, accountability, that you may have seen, that you may be more familiar with hearing. And these do, in fact, get a lot of very well-deserved attention, of course. And why do I say that they are tied to the right to contest? Well, first of all, we need any process to be transparent and to make sure that if you are being subjected to an algorithmic decision, you know, so that then you can decide to contest it or not. And at the same time, you also need to be aware of how to do that and what are the processes put in place for you to contest if you want to. Then there is a very important notion of explainability. And in this case, it means that to know if you agree with a decision or not, you probably need to understand what the decision is and how it was taken. And then you can make an informed decision on whether you would like to contest it or not. And then finally, accountability, which is a very important keyword, in this case is about the process after you have contested. If a fault is found, how should you be compensated? Where does the fault lie? And so on. Now, these are definitely incredibly important topics, but a lot of the time it is assumed that if you have transparency, explainability, and accountability, then that's it. You have the right to contest almost automatically. And in fact, one of the ideas of our paper is that no, contestability is its own research problem that will require its own kind of techniques and methods for a very simple reason, which is that when you contest a decision that has been taken about you, you are looking not at the algorithm or anything as a whole. You are looking at that specific decision. But not only are you looking at a single instance of a single decision, you are looking at it not about, okay, what is the decision? Can I understand the decision? Can I understand the process that led to it? You are also looking at whether this process followed the relevant rules, the relevant regulations, the expectations that you have of this process. So in fact, it is not so much that you are trying to understand the process, but you are trying to see whether it was done correctly, whether it really followed the rule of the law, the expectations that we have, fairness. So in contestability, there is much more, the context is much more important, perhaps, than in explainability, where you focus about how the decision was taken and what the decision is and explaining it. In contestability, you really have to understand the context and what kind of expectations there are on the process to see if those expectations were fulfilled or not. So basically, I am going to talk a little bit about what kind of assurances we need to guarantee contestability. And then after, I will propose a simple, very preliminary approach of the type of methods that we are looking at for proposing techniques to deal with contestability. So the first thing that we really need for a contestability process is that policies and the requirements that are put into this type of algorithmic decision should be clear, right? So policies should really openly specify what the regulations and the adequacy determinations for the European Union is moving a little bit towards this side. I mean, like I disclaimed, I am not a lawyer, but in our group, of course, we do look at the kind of laws that interact with intelligent systems. And the EU is drafting some new laws, and they have very specific application areas for which certain rules apply. So we need, of course, clarity into what are the rules to be able to check whether the rules were followed. The second thing that we need for contestability for sure is pre-established procedures, so that when you get this decision taken about you, you already know what the procedure for protesting is like, and you can take it forward. And this procedure doesn't have to be invented each time there is a possible complication or there is a contest raised. And finally, of course, tied to accountability that I was talking about before, we need processes that then support, mitigation, compensation, attribution of accountability when a fault is found. And all of these points us towards the fact that we don't only need, completely technical solutions, that there will be this machine where you input this decision and it tells you, yeah, this decision was fine or this decision was not fine. Of course, all of the constraints, all of the requirements, and all of the process for that come from society. So we have to look at those as well. So we need socio-technical solutions. Socio-technical is a very loaded word. It's used a lot in many areas. So I hope that when I present an idea for a procedure, you will see what I mean. So this is a very preliminary contestability proposal. And I am not going to go into it in detail. In particular, we have worked with some formalizations, and I don't think this is the point of this talk. The point of this talk is really to say, well, there are these type of options and these types of ideas floating around, and then open the discussion to you all so we can talk about the right to contest. And I do hope that more people will focus their attention on how to guarantee the right to contest, because I think it's a really pressing and important problem, and that eventually our society is going to need some answers. So about our proposal for contestability, well, we propose that a way forward is actually not to reinvent the wheel, but to combine well-established software engineering practices and rule-based approaches. Now, this should not surprise you because I am a logician, so I will always propose rule-based approaches. But I hope I will convince you a little bit that this could be a way to do it. So the main idea of it is that with any contestable automated system, you will have a formal specification in which all of the constraints that apply to this system are encoded. And whenever there is a contest, you basically are able to run the specific decision against these formal specifications and see whether they are being fulfilled or not. So in a way, you rerun the decision, and if there is some part of the process that does not adhere to the specification, some flags are raised. And then you can see where exactly the process was not correct. Now, I said that this was a socio-technical solution. So now I've talked about the technical part, but where is the socio part of it? And the socio part of it is actually, in fact, in itself quite difficult, because it involves really understanding what the requirements are for the system and putting them into words that apply to the system itself. So relate all of these requirements that we have to specific functionalities of the system, of how the system should work in terms of its functionalities. And for these, I mean, there are many proposals in the literature, and I will be happy to point you towards some of how really to involve stakeholders, policymakers, everyone that should be involved in the process to arrive at very concrete constraints on the system. The second part of this process then would be to take all of these very precise constraints and put them into some sort of formal language that could encode these formal specifications. And this language not only needs to be able to explain, to encode these specifications, but you also need to be able to use it to monitor whether they are being followed or not. And for that, I also, we actually have one language that we have done that for an example, and but I have several proposals of what kind of languages are needed. And finally, the final step of this process is indeed that when someone contests a decision, you run this decision against these specifications and then raise flags on whether the process was followed. And for these, you are going to need probably more information than just the decision itself. You may need to know, the specific version of the algorithm that you were using was, if it is something that keeps updating itself. You will probably need, a record of previous inputs, previous outputs, and of external events, maybe. So I would like to basically finish, reach the final part of this talk by raising an actual real life problem. And my aim with this real life problem is to show that, in fact, this is something that already happens, that we need to check algorithms to see if decisions that were taken were correct and due to process or not. And also to show that all of the things that I just mentioned that we need, sometimes people say, oh, but maybe you are requiring too much of developers, that they should, collect all of these constraints and keep track of all of these events and keep all of these records. But in fact, as you will see with this real life example, in any case of contest, this is exactly what we go as humans and look at. So it's not that, you need extra things for this type of process. Is if you are going to be guaranteeing the right to contest, then this is the type of record keeping and participation that you are going to need. So on to the real life problem. I think it was maybe, I don't know, I want to say less than 10 years ago, maybe less than 5 years ago, that Lufthansa's pricing algorithm started increasing prices up to 30% right after Air Berlin went out of business within minutes. So of course, customers thought, okay, this is a bit weird and maybe they are abusing, the monopoly laws and I don't know what is going on. So they raised the contest. They went and complained to consumer protection. Which, sorry, but I am not going to pronounce because I don't know how to. So we will call it consumer protection. So Lufthansa's response at first was to say that, well, the algorithm is autonomous, so we don't really have, much responsibility here. But of course, consumer protection said that the fact that it was an autonomous algorithm rather than a person would have no bearing on their decision, and that if the price increase was incorrect, then of course Lufthansa would be held accountable. So how did they go about checking whether these price increases and the particular instances where people had gone to buy tickets and had gotten these inflated prices were correct or not? So the first step, in fact, was very similar to ours, which was requirement collection. And they went and checked all of the rules that applied to this type of prices. For example, that in an airplane, cheaper tiers must be fully booked before more expensive tiers are available, and that you need to have prices that are comparable to previous years, and so on. And in fact, in our case, if we were to use the process that I proposed, then the only extra step required here is that when we say comparable to previous year's prices, we would need, some kind of formal requirement of what that means. So you can translate it, for example, to no more than 30% from the average price of last year or of the previous 5 years or so on. And of course, to be able to do this kind of translation, you need communication with the stakeholders, with consumer protection, with the relevant legal authorities that can tell you, yes, this is a safeguard enough. If you check this, then we will accept that this was similar enough to last year. The second step then, once we have these type of constraints, is to build your compliance contract. And like I said, there are many languages in which we could do that in, and here I have some proposals, but I'm not going to go into them. I am happy to talk about it afterwards, but there are many ways in which you could formalize these constraints in a language that makes it monitorizable. And the final step then is just, okay, if we have this situation and people say, oh, I think that the price you gave me was wrong, then you can go and rerun this decision under monitoring and see if the constraints were followed or not. And for that, we actually need record of inputs. We may need event occurrences. And in this case, for example, you need to know when a previous tier was sold out, so you can make sure that the most expensive tiers were not made available before the cheaper ones were sold out. And you also need to know about the world. You need to know about the prices from last year and from the day before, and so on. And basically, this is exactly what consumer protection did, except in a more, let's say, manual way, and also in a more ad hoc way, because they didn't have a system in place when these contests were raised. And they checked, whether the process sufficiently adhered to these constraints. And actually, Lufthansa was cleared because the prices were sufficiently close to last year's, to their satisfaction. All in all, I mean, I am done. Like I said at the beginning, if there is only one message for you to take away from this talk, I hope it is that contestability is in fact not a given, and that even though we now have many active research areas into all aspects of law into AI and ethics into AI, the question of contestability tends to be kind of overlooked, but it is in fact not actually encompassed by the other questions. So we should look at it also in its own right and find methods that help us make our algorithms contestable. And I think that's all I wanted to say for today.